I'm going to pick up right where the last video left off with number 4 on the worksheet. So we have a rectangular Persian carpet has a perimeter of 184 inches. The length of the carpet is 28 inches more than the width. What are the dimensions of the carpet? Okay, so let's just sketch the carpet. We'll just draw a basic rectangle to represent this carpet. Okay, and we know that the perimeter, that's given in the problem, the perimeter, a rectangular Persian carpet has a perimeter of 184 inches. That means the four sides together, when added up, give you 184. Now what we don't know the width, and we don't know the length. So this word dimensions, that's another way of saying the width and the length. So that last sentence, what are the dimensions of the carpet? That's another way of saying what is the width and the length of the carpet. So that's what we're looking for. Now, one of these two we'll call X, or you could use W or L, whatever you want. What we don't want to do is use two variables. We don't want to say, okay, well, we'll call the width W and the length L. We don't want to do that. We want to stick with only one specific symbol. If we're using two variables, that means we need a system of two equations, and that's definitely something we don't want to do. So what if we call the width W and then the length something with a W in it? All right, so the length of the carpet is 28 inches more than the width. So let's use that. The length is, remember, is equals, so there's an equal sign. So we have the length of the carpet is equals 28 inches more than the width. That means the width with an additional 28. So the length, we could call this the width plus 28. So there's your 28 more than the width for the length. So now we could label this diagram. That's this side here is the width, and this side is the width, and this side here is the length. So we could call that W plus 28 and W plus 28. All right, so now we could create an equation to use. And we know something about the perimeter. And by definition, the perimeter is the sum of all the sides. The perimeter is equal to all the sides added up. So we know this. Perimeter is sum of all sides. All right, so let's put that into an equation. The perimeter, well, we know that is 184 is equal to, now the sum of all the sides. Well, there's four sides there. There's a W, the width and the width, and then the length and the length. W plus 28 plus W plus 28, or basically the left side, the right side, the top side, the bottom side. So those four sides added up should give us the perimeter. All right, and if we look at the right-hand side, we've got a W here, 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 and here we have four W's. So we could say 184 is equal to 4W, and then we have a 28 and a 28. So 28 plus 28 is 56. So we could say 4W plus 56. All right, so now we could solve this equation for W. To isolate the W, to get W by itself, we've got to get rid of the 56 and the 4. So we have two numbers to get rid of, two steps to do that. So to get W by itself, let's get rid of the plus 56, and we do that by subtracting 56 from both sides of the equation. So on the right-hand side, those 56's cancel, one positive, one negative. So we're left with 4W. And on the left-hand side, we have 184 minus 56. And that should be 128. Right. One more thing to do. Now we have 4 times W. We want to get rid of the times 4. We do that with a divide by 4. Let's come over here so we have a little bit more room. All right, so the times 4, the divide by 4 on the right-hand side, they cancel, leaving us just with a W. And on the left, we have a 32. 128 divided by 4, if you want to use a calculator for that, the width is 32. Now, we haven't answered the question fully. The question doesn't say what is the width. It says what are the dimensions, meaning the width and the length. So if we take this answer for W and bring it back up here, well, we've just found out that the width is 32 inches. And the length is 28 more than that. So now that we know the value of W, remember W is just a temporary placeholder for the number until we figure out what that number is, and we just figured out it's 32. So if we plug in a 32 for W, or replace the W with the 32, 32 plus 28 equals 60. So the dimensions of this carpet, 32 by 60, or you could say the width is 32 and the length is 60. All right, let's move on to number 5. A baseball team played 150 complete games last season. Okay, 150 games played. They had 14 fewer wins than losses. How many games did the team win? Okay, so let's start with that last sentence. How many teams did the game win? So we're looking for number of wins. We don't know how many wins there were. That's the whole point of this problem. So we'll call that X. We don't know how many it is, but we know it's a number, and let's let X represent that number. But we also don't know how many losses there are. And we can't talk about wins without talking about losses. Now, what's the relationship between the two? Well, they had 14 fewer wins than losses. All right, that means they had more losses, less wins. So the number of losses has to be more than the number of wins. And if the number of wins is X, and if the wins are 14 less than the losses, well, the losses are 14 more than the wins. So we could call the losses, the number of losses, X plus 14. So now you can see, if the wins are X and the losses are X plus 14, that means the number of wins is indeed 14 fewer than the number of losses. And from the problem, we could see that the number of wins plus the number of losses, that must equal the total number of games. There's no other option. There's either wins or losses. So every game is either a win or a loss. So if you take all the wins and all the losses, that must equal the total number of games. So now let's translate this to an algebraic equation. The number of wins, we're calling that X. The number of losses, we're calling that X plus 14. And the total number of games played, well, that's given in the problem. That's the 150. All right, so let's simplify. We have two X's on the left-hand side, so let's call that 2X plus 14 equals 150. And now our goal is to solve for x. So we want to eliminate the 2 and the 14 from the left-hand side. The opposite of the plus 14 is the minus 14. And if we subtract 14 from the left, we have to also subtract 14 from the right. So plus 14 minus 14, they cancel. We're left with a 2x on the left-hand side. And 150 minus 14 is 136. Now we're just left with the times 2 we need to eliminate. So the opposite of times 2 is divide by 2. Let's divide both sides of the equation by 2. So on the right, we have 136 divided by 2. On the left, we have 2x divided by 2. So the times 2 divided by 2, they cancel. And we have x is equal to, well, 136 divided by 2 is 68. So x equals 68. Going back to our original definition of the symbol x, that means the team had 68 wins. And although the question isn't asking about number of losses, now we know how many losses there are. Whatever x is 14 more than that, so x plus 14, or 68 plus 14 is 82. And if you want to double check this, 68 plus 82 is indeed 150. All right, one more to go in this video. So let's look at number 6. A high school graduating class is made up of 414 students. There are 62 more girls than boys. How many boys are in the class? Now, I want to just take a moment, and I'm going to put both questions on the screen at the same time. So let me make this a little bit smaller so they both fit. Notice that problem 6 is almost an exact copy of number 5. Now, in number 5, we're talking about wins, losses, and total games. In number 6, we're talking about boys, girls, and total people. But essentially, it's exactly the same scenario. And whether those objects are games or people, the mathematics is exactly the same. So you may want to pause the video at this point and try to solve number 6 in the same way that we just solved number 5. Okay, so for number 6, a high school graduating class is made up of 414 students. Okay, that's the total number of students. Now, assuming everyone is either a boy or a girl, there's 62 more girls than there are boys. How many boys are in the class? Well, we don't know the number of boys, and we don't know the number of girls. Even though the problem is only asking for number of boys as your final answer, there's still 2 unknowns floating around here. We don't know how many boys there are. We don't know how many girls there are. But we know the relationship between the 2. There are 62 more girls than boys. So that's how the 2 are related. So if we let the number of boys be x, well, we know there are 62 more girls than boys. So if we take the number of boys and add 62, that is the number of girls. And so you'll see the theme through so many of the word problems in this video, my previous videos, is that we're only using one variable. Normally the letter x, sometimes something else if it makes sense. Like in the previous problem, they'll use w for width. But regardless, we're using only one single variable, and we're using that to represent multiple different things. Because not everything is just an x. Here we have the symbol for boys is x, the symbol for girls is x plus 62. And so from the problem, we know that the number of boys plus the number of girls, well, that should equal the total number of students. And so now we could translate this thought into a mathematical equation. Well, the number of boys, we're calling that x. The number of girls, we're calling that x plus 62. And the total number of students, that's given. That's the 414. And now we'll proceed almost identically as we did in number 5. The math is exactly the same, we just have slightly different numbers. So we have 2x's on the left, so we could call that 2x plus 62 equals 414. And so you'll see once you when the problem is expressed in words, when it's a word problem, different problems sound different. They sound sometimes significantly different. But once you eliminate the words from the word problem, once you create your equation, now you see very similar situations among many, many different sounding word problems. All right, so to get x by itself, to isolate the x, we need to get rid of the 62 and the 2. So 2 numbers to eliminate, 2 steps to do that. So we could get rid of the plus 62 with a minus 62. So minus 62 from both sides. So on the left, the positive and negative 62s, they cancel. We're left with a 2x. And we have 414. Subtract 62 from that. We will get 352. Now finally, we have 2 times x. So to get rid of the times 2, we will divide by 2. And on the left, the x times 2, divide by 2, the 2's cancel. So we have x is equal to, well, 352. Divide that by 2, we get 176. So x is equal to 176, and from the very beginning, x is the number of boys. So that answers the question. And we could just as easily have found the number of girls, because the number of girls equals the number of boys, which is now 176, plus 62. So we know the number of girls is 238. All right, so that does it for this problem set. And again, as I've said before, developing a level of comfort doing word problems is not something you learn in one assignment or one lecture or 1 week. This is something that we're going to develop over the course of weeks and months. So this is basically a fundamental theme for the entire class: word problems. So just if there's still some confusion now, if there's still some frustration now, that's perfectly fine. That's perfectly normal, and it's expected. But the only way to get comfortable with word problems is to do a lot of them. All right, so that does it for this video. I hope it was helpful.